this video, we are going to use Coulomb law to calculate the electric force on two charges. And this is the situation we have. Your text would read something like this. You have two charges. Charge 1Q, one is the minus 6 microcoulomb. Charge 1, charge 2 is the minus 14 microcoulomb. This is the charge. It is good idea to draw this your page so you have a kind visual, and then you would make down maybe that the distance between the charge is 10 centimeters. Now in this problem we are going to figure out what is the force on charge. Charge 1 from charge 2. Now we are going to use Coulomb's law to calculate the magnitude of the charge, not the direction. We are just going to think for the direction. We have a negative charge, and negative charge like charge repel. So which V is Q when going to be forced or pushed or pulled. We want to know that is the direction of the force on charge. From charge, well, that charge is going to feel a force that is to the left. It is going to be pushed away. They are going to repel each other, which means are going to move apart. If it is going to move, the left half feel force to the left, and we would designate that force as F1 to F pair force. That says 1. This is not 12. This is the force on 1, on charge 1 from charge. So that's how we figure out the direction of the charge. Now we use Coulomb's law, K, Q, 1, Q2 divided by the square, the distance between them. F stands for force electric, to calculate the magnitude of the charge. Now we need to remember that K is equal to the constant, and it is always have 9 times 10 to the 9th 10 to the 9th Newton meter squared Coulomb squared. After that, it is really just plug the number in and go. So we are going to plug the number in K. When it is written out front here, really goes on the top. So it is K times Q1 times Q2. So we are going to write down 9 times 10 to the 9th Newton meter squared Coulombs. Square. Now when we write down the charge, we don't put the sign whether it is negative or positive, or of course we wouldn't write down really it is positive. We don't put a positive down typically, but negative we don't write down negative. We are just figuring out the magnitude. You might think of, if I use the positive negative, it is tell me that direction. It doesn't work. That we just put the amount of charge, not the sign. Okay, so this is the 6 times 10 to times 6 Coulombs. Once again, we are not going to put down minus 14. It is just 14 times 10 to the minus 6. Always put down the positive value. Now you will notice that in the microcoulombs, we have to convert both of these into coulombs because our constant is in coulombs. Easy to do that. 6 microcoulombs is just 6 times 10 to minus 6. 114 microcoulomb in the just 14, not 1.4, 414 times 10 to minus 6. That this sample means a micro means 10 to minus 6. It was nano, it would just be 10 the minus 10 pico minus 12. So you didn't really have to do whole of mass. I mean, you would do the conversion on piece of paper, but just stick a 10 to minus 6 for micro or 10 minus 9 on that pack of columns, and you will have your columns. or micron. Okay, now the other things, it is the distance is squared, but this in centimeters. The distance has to be in meter. So you are going to have to convert that into meters, and 10 centimeter is 0.1 meter squared. Now you will notice we want to calculate a force. We have newtons, meter, coulombs, and meter all over the place. We want to get rid of everything. We want everything to get of itself except for the Newton. So you see have columns and columns here. That column square will these two columns will cancel with the column square. This meter squared, because this is squared, this kind of meter squared. Also, this is the meter square, which is down here, is going to cancel with this meter squared. So all you do is you multiply this number times this number times this number, and then you have to divide it by the square of the distance, even though you cancel the meter square. This square is for the unit and the value, so you will still have to count multiply the 0.1 by itself or square the 0.1, so it is 1, 2, 3 multiplied divided by 0.1 square, and you should come out with 75.6 newtons. And we already said earlier that just the magnitude, we didn't put the sign, the negative sign in, we just take the positive value. This is the magnitude of the force. We consider the direction area by thinking about whether we had like change or opposite change. In this case, the force on one form is to the left. Okay, now it is also true that charge number 2 feels unequal, but opposite force, so the force on charge 2 is 75.6 newtons also, but the direction of the force is to the right. And this problem we were asked to find what is the direction in attitude of the force on charge 1 from charge 2. So I think that really pretty straightforward once you have the values and the equation and the constant, just plug everything into. The mass convert these two columns square the distance, and don't put names and positive signs in the chart, just use the positive values.